Let's do some problems. The graph of the quadratic function intersects the y-axis at this point and has a vertex at this point. Let's go ahead and write that on the diagram. Write down the value of c. The value of c is the y-intercept, 5. By using the coordinates of the vertex, b, or otherwise, write down two equations in a and b. So what we have to do is we have to use two data points that we plug in here and to solve for a and b. So the two data points, am I not allowed to use this one? I can't use this one because the x terms go away, the terms with a and b. So I'm not allowed to use this data point to plug in here. So I'm going to use this data point, and remember the vertex is also on the axis of symmetry. So this data point that's here also has an equivalent data point over here. Since this is 4 from the axis of symmetry, this one is also 4 from the axis of symmetry. So the data point's 8, 5. So I'll use these two data points to plug into this equation, which eventually I'm going to use to solve for a and b in part c. Let's go ahead and plug in those equations. The y value equals 13 when x equals 4. And the y value equals 5 when x equals 8. So go ahead and do some math here to go ahead and solve for a and b. Subtract 5 from both sides. I'm going to multiply this one by 4. So I'm going to multiply this whole equation by 4 to get these to cancel out. So first I'm going to subtract 13 from both sides. Now I'm going to multiply it by 4. So now I'm going to add together my two equations, these two equations, or I'll subtract them, I guess. Let's go ahead and subtract this. That goes away. So 0 equals ab minus 32. B equals 4. This is part B. I don't know what they want, if they want this or this. B equals 4, and I can plug that into this equation. So 0 equals 64a plus 8 times 4. So I just looked up the answer to this, and there's an alternative second equation. It's true that this needs to be one of your equations, but we also have the x value of the vertex is equal to negative b over 2a. So we could also use this as well, that 4 is equal to negative b all over 2a. So we can also use this as our second equation as well, not just this. If we were to do that, we could solve this equation for b. Multiply both sides by 2a. Multiply both sides by negative 1. So b is equal to negative 8a. And we could then take that and plug that into this equation, or this equation. Let's go ahead and try that over here. I'm going to try and squeeze that in over here. So 13 equals 16a plus 4b, and 4b is negative 8a. Plus 5. Let's go ahead and bring that 5 to the other side. We have 16a minus 32a. So we combine those two terms, divide by negative 16, and you get a is equal to negative 1/2. You can take that and plug that back into here. We said b is equal to negative 8 times a. We found out a is negative 1/2, so b is equal to positive 4. Alternate way of solving the set of linear equations.